everyone. Welcome to the Predictive Playbook classroom. In this video, we're going to break down a real NBA betting algorithm, but not with the purpose of predicting a single game, but to show how statistical testing can help separate real edges from just random luck. We'll use the Hawks versus Mavericks game tonight, and the Hawks are a favorite in this game. But remember, during this video, it's a little bit different than I usually do. The focus is on the process, the probability, and lastly, the p-values, concepts that I've mentioned before, but have never really defined in a video for everybody to understand that wants to understand it. So the educational disclaimer is simply that this is for educational purposes only. It's about analytics, statistics, and hypothesis testing, and it's not financial advice. Past performance never guarantees future results, and nothing here is meant to encourage irresponsible behavior. The goal is understanding how to evaluate betting systems and algorithms and not chasing outcomes with gut feelings. Let's move on to the first slide here, and this is a typical binomial distribution. And I'm not going to get into the math on this one. But in the system that's coming up, there's 38 wins, and that's what X greater than or equal to 38 represents when the highlighted tail is mentioned as the title. But you can see that between basically 14 wins and 30 wins, that's about 90% of all the games that were bet using this algorithm. And in a second or two, I'm going to show you why these are very important. So the agenda is simple. We're going to work on the algorithm and its filters. And we're going to identify market mispricing, binomial models, and p-values to use to test the results. Are they meaningful, or is this just random luck? A lot of people can backfit any trend of a team, a league, a NCAA tournament, and I guarantee you in my database I can find ones that are 20-0 against the spread. And you know what? It has little meaning in terms of predictive power. So let's move on to the next slide here. And these are just the formulas that are used in the binomial calculation. If you want to get the detail, just send a comment or email me, and I will get back to you with the details on this. But it's not important to understand how the math is calculated. It's important to understand the process of what these algorithms go through and how I develop them. So in our example, the matchup is the Hawks versus Mavericks. The Hawks are the road favorite and listed around minus 7.5 points currently. The game isn't the point, however. The point is how we evaluate whether a system has an edge. Is there an edge in this game or not? And regardless of just one single result, it spreads out over decades of results to come up with the correct, meaningful application. So algorithm performance overview. Let's take a look at this. This is pretty impressive. This goes back to 1996, straight up 38-7. So that's pretty high probability right now that Atlanta Hawks will win this game. But is there a correlation, or is this just random luck? Against the spread, it's 27-16 with a couple of pushes. These numbers look impressive, but numbers are not enough. The key question is, could this happen just by random chance? Every play in this system must meet all these criteria. The team must be a road favorite, on a long win streak, heavily favored, coming off an ATS win and playing after the All-Star break. These filters are designed to reduce the noise of possible series of results that are basically getting 500 or worse. But they also reduce sample size, which makes statistical testing even more important. And why the road favorite? Road favorites. Historically, markets tend to overvalue home court advantage. Elite teams often travel well, and when they're dominating, odds makers can be slow to fully adjust to the new style of winning form. That delay, it's not a prediction, is where potential edges come from. So it's a public betting lag, if you will, where the market is not catching up to the quality of the play, in this case, the Atlanta Hawks. Now we'll get to enhanced performance of 10 or more win streaks, which the Hawks are on. When a win streak reaches 10 or more games, performance improves even further. Straight up results jump to 87%, and against the spread, performance improves as well. This clearly suggests that extreme dominance may expose market lag more clearly than shorter streaks. Conversely, sometimes we have a tendency to think, oh, wow, the Hawks are on a 10-game winning streak. They're due to lose. Nothing is due to lose. If you flip a coin and heads comes up 10 times in a row, it does not mean that tails has got a better than 50% chance of showing up. It's still the same mutually exclusive coin flip as all the 10 previous coin flips were too. Let's get to the Bernoulli model now. This is getting a little bit out there in the mathematical world, but again, just understand that it's Bernoulli trials, and this is the math that's used to tell me how these parameters are working together. Do they correlate, or is it just random? I often used on the shows in the past where just because Miami Dolphins are 15-2 against the spread, if the team bus eats at McDonald's and goes through the drive-through and playing on a Saturday night, that has no meaning whatsoever. And that's an extreme, unrealistic thing. It's not part of the real world, but I think you get the point. So now let's model this properly. Each bet is treated as a Bernoulli trial. It either wins or loses. Under the null hypothesis, the system has no edge, meaning the true win probability is 50%. The alternative hypothesis is simple. The win probability is greater than 50%. Now let's get to the p-value now. The p-value is the most important statistical measure I use in evaluating algorithms and if they're going to make us money. And that's the most important thing. It will have losing streaks, but over time, does this thing make money consistently year after year after year? So what we have here is the p-value answers to one question. If there is no edge, how surprising is the result we observed? In other words, is it random luck only, or is there a little bit of correlation going on? The smaller the p-value, the less likely it is that the result occurred by random chance. So again, the closer it gets to absolute zero, the less likely it is that results occurred by luck. So starting to get to the p-value, you must use the binomial distribution. The observed wins were 38, as you can see on the chart. And this probability is extremely small under the randomness. So 38 wins out of a test of 45, that's 38-7, straight up. That's an extremely small sample size to be considered as random. So now we get to the next slide here, and here's the normal approximation. In other words, intuition. The interpretation is the result of a factor called sigma. So a 4.5 sigma event is extraordinarily rare by chance. So here we're getting closer and closer to determining whether this is a real thing or whether it's just random. So let's get to normal approximation. So normal approximation is the next step in finding the p-value. So in this situation, we have a subset of 10 plus wins, 13-2, even smaller sample size, obviously, but a much higher win percentage. And the p-value is calculated, the sigma is 2.6, which is extraordinarily rare. P-value is 0.005. Anything under 0.02, and some people even use 0.05, is considered not random, that there is something to this and meaningful between the parameters we've chose to make this algorithm. So a 0.005 p-value simply means that only a 0.5% chance of this being random under a fair system evaluation. So then we have the ATS part of it. How does this work against the spread? Because that's what is really meaningful if you're going to consider making a bet. 12-3 ATS for 80% winners, which is outstanding. There's only 15 sample size, and K equals 12, which K stands for wins in the formula. So if our sigma is 2.1, the p-value is 0.02. Still statistically meaningful, but notice how it went from 0.005 to 0.02 in the subset. Even though the win percentage is 80% and higher than the previous one, it suddenly becomes almost meaningless to me to have a subset that says, oh, if it's greater than 7 wins and now it's 10 wins, How relevant is that? Is that more relevant? No, it's not. So it clearly states in mathematical terms that 7 wins or more is the key observation. So now that I've put everybody to sleep, we're going to summarize this whole thing real quick. Road favorites: extended win streak, post All-Star timing, market adjustment lag due to the win streak, and we have a sample play for tonight on the Hawks -7.5. So the key takeaways: the filters matter more than the volume of bets. P-values separate luck from gut feelings. The extreme streaks expose pricing delay in the market. The public isn't catching up, and the books aren't catching up either, because the public is not recognizing the true value of what the Atlanta Hawks are doing right now. And again, this doesn't mean that the Hawks are going to win tonight. It clearly does not mean that. What we mean to say here is that we have an edge on the Hawks. We think they're going to cover the 7.5 point spread quite easily, and it's just one pick of several hundred over the course of a season. So the bottom line is we don't predict outcomes. We just simply price probabilities of events occurring. This is something I learned on Wall Street in predicting outcomes, especially ones where you can risk very little and market surges and you make a lot. It's risking a little to make a lot is what this service is all about. So that will take care of the show for today. Just remember to be safe, use your head, never bet over it, and may all the wins be yours.